Hello my dear students, welcome to video number 150 of my channel MALACHEMPHILIC. Now I am doing the course on inorganic semi-micro analysis and today's topic is preliminary examination of the salt second part. In the first part already I have discussed dry test tube heating, flame test and borax bead test. Today I am going to discuss this charcoal cavity test and fusion test for chromium and manganese. So let's start. Charcoal cavity test. Here you have to heat the salt with double amount of the sodium carbonate. That means you have to mix the salt with double amount of the sodium carbonate and you have to heat it in the reducing flame. Then you will get the colored residue. From the color of the residue, you will get the idea about the cation present. Now, what is the reason behind this colored residue? See, here what is happening? You are taking this, say you are taking the salt, say copper sulfate, and you are heating it with sodium carbonate. Then first step is the double decomposition whereby exchange of cation anions takes place. That means here you will get copper carbonate plus sodium sulfate. Now this copper carbonate, because you are heating, on heating it will be converted to the metallic oxide. Say here copper carbonate on heating it is converted to copper oxide and here it is carbon dioxide gas will be evolved. Okay. And this copper oxide or the oxides of the metal, this will give the characteristics color. Now again what happens, some of the oxides will be reduced in this reducing flame. Already I told you this charcoal cavity test must be done in the reducing flame. Reducing flame means where the fuel is burned in insufficient oxygen. So some of the carbon particles will be there. By that carbon particles, these oxides will be reduced to the metallic state. Say here, this copper oxide plus this carbon of the reducing flame, it is converted to metallic copper. This copper oxide is black, cupric oxide. Now it will be converted to metallic copper, which is reddish brown. All of us, we know the color of the metallic copper, and here carbon monoxide will form. Okay. So you will be getting, after heating, you will getting the coloration either for this oxide formation, oxide residue, or sometimes the metal. Okay. See, charcoal cavity test on heating the salt mixture in sodium carbonate. First, the corresponding metal carbonates are produced by double decomposition. Then these carbonates are decomposed to corresponding oxide. For some metals, the metal oxides are left as colored residue. What I told. The color of the residue being characteristics of the basic radical present. Metal oxides may undergo reduction to metallic state by the reducing action of the carbon of the charcoal, resulting in the formation of the metallic beads of easily fusible. So this reduction takes place in the not only the reducing flame, but even the charcoal, carbon of the charcoal. Now, this part you listen carefully. The metal so formed volatilizes in the form of vapor. So, after reduction, metal is formed which is volatilized in the form of vapor, which burn in the air to form oxide. Okay, again it is forming oxide. These get deposited in the form of layer or crust around the cavity. That is known as incrustation. So that metal oxide again deposited in the form of layer or crust around the cavity, that is known as incrustation. Now coming for the procedure of charcoal cavity test. Here, first what you have to do, you have to take one charcoal block and you have to make a hole with the help of the borer. So make a small cavity in the clean charcoal block with the help of the borer. Then you have to mix the salt with the double amount of the sodium carbonate, and that mixture you have to take it in the cavity on the charcoal block. So fill the mixture of 1 part of salt and 2 parts of sodium carbonate in the cavity. Then what you have to do? You have to just add 1 or 2 drops of water and press it with the spatula so that it will stick to this cavity. While heating, it will not fall down. Okay. So they press the mixture with spatula and moisten the content of cavity with a drop of water. Then now what you have to do? This charcoal block, you have to hold it by the tongs by left hand. Okay, with the help of the tongs by left hand, you have to hold it, and you have to take the reducing flame, and with the mouth blowpipe, you have to blow this flame to this charcoal block where the content is taken, right, for 2 minutes. Then you have to blow the flame, then it will be heated. Now we observe it in the hot condition as well as in the cold condition. What is the color of the residue? So hold the charcoal block in the left hand and hit the reducing flame with the mouth blowpipe for 2 minutes. Observe the color of the residue in the cold and hot, the color of the incrustation, residue or incrustation if any, and the bead formation. You observe the color. Now here 2 things you have to note. Do not make a shallow cavity or a very deep cavity. If you make a shallow cavity while heating, that mixture may fall down. If you make very deep cavity while boring it, that charcoal block may break, or while heating that you have to put more amount of the mixture. It is a wastage of chemical. And the second point is always bore a fresh cavity for a new salt. So what are the observation? If you get yellow residue and incrustation when hot and white residue and incrustation when cold, that indicates zinc. Reddish brown residue and incrustation in both hot and cold, cadmium. Yellow residue and incrustation, grey and soft metallic bead marks paper, that is lead. Then red residue and reddish scales or beads, that indicates the copper. Then black residue and beads which does not mark on the paper, that indicates iron, cobalt, nickel and manganese. And then white residue means aluminium, magnesium, calcium, barium, strontium and zinc. Now coming to cobalt nitrate charcoal cavity test. When you are doing charcoal cavity test, if you get the white residue in charcoal cavity test, say just now we have seen white residue means it will be this zinc, aluminium, magnesium, calcium, barium, strontium. So if it is white, then only you have to perform this cobalt nitrate charcoal cavity test. Here what you have to do, that mixture, what you have heated in this charcoal block, in that mixture, you have to add 6 to 8 drops of cobalt nitrate. Okay. Then you have to heat it. So this cobalt nitrate, when you are heating this cobalt nitrate, then what happens? It will decompose and form the cobalt oxide. Cobalt nitrate, on heating, it decomposes to cobalt oxide plus this nitrogen dioxide and oxygen gas. Right? Both are gases. Now this cobalt oxide, it combines with this metal oxide, that residue already it was there. Say that means cobalt oxide plus I'm taking this zinc oxide, then it forms, combined with this and form a colored compound. Say here it is cobalt oxide, compound is like this, zinc oxide, and this color is green. Now if you take cobalt oxide plus aluminium oxide, then you will get this compound, cobalt oxide, aluminium oxide, and this color is your blue. And if you take magnesium oxide, that means if the magnesium salt is there, then you will get this compound. This color is your pink color. This color is your pink color. Okay. So from this color, you can identify the cation. It is mainly for this zinc, aluminium and magnesium. These three colors are obtained. Now coming to the fusion test for chromium and manganese. This is the special test for this chromium and manganese. These are almost confirmatory tests. See, in the fusion test, what you have to do, just you have to take sodium carbonate, then on that you have to take the salt, your salt, and then some potassium nitrate or potassium chlorate, little amount, and the molten sodium hydroxide, or you can take sodium hydroxide mix also. So take little of the solid sodium carbonate on a mica foil. You have to take it on the mica foil. Now sprinkle a little of the salt and a little potassium nitrate or potassium chlorate and on the molten sodium hydroxide. Now what you have to do, this mica foil, you have to heat it strongly till it is fused. Okay, so continue heating till the mass fuses completely. Then you cool and observe the color of the residue. Then if the color, if you get the green mass, that indicates the manganese. And then this one, you have to first filter it and then you have to add nitric acid, you get the pink coloration. So green mass indicates manganese compound. Dissolve the green mass in water and filter, acidify the filtrate with dilute nitric acid. Then you will get the pink color, development of pink color. Next, if you get the yellow mass, that indicates the chromium. So what you have to do, again dissolve this mass in water, then acidify and filter, acidify the filtrate with the acetic acid and boil of carbon dioxide and add lead acetate solution. You will get the yellow precipitate. This is the formation of yellow precipitate which indicates chromium. Now coming to what is the reason for this fusion test for chromium and manganese. So you are heating this salt, no, sodium carbonate. So when you are heated, it is converted to oxide. Say it is chromium trioxide, Cr2O3. Plus you have this sodium carbonate. Okay, and you have this oxygen from this potassium chlorate. Then what you are getting? You will be getting this sodium chromate. Same equation you can write with sodium hydroxide also, plus sodium hydroxide plus oxygen. Then it is sodium chromate. Now, what you have done it, you have to dissolve along with the mica foil in water and then you have to filter, and that filtrate you have to just acidify it with acetic acid and boil of carbon dioxide, and you have to add lead acetate solution. That means this sodium chromate, which is yellow in color, there we are adding the lead acetate solution. So Na2CrO4 CrO4 plus lead acetate. Then you will be getting the precipitate of lead chromate, that is PbCrO4. This is yellow precipitate. Now, In case of manganese, what happens? This same equation, manganese oxide plus sodium carbonate plus oxygen. Here we will get the sodium manganate. Okay. And the same equation we can write it with sodium hydroxide plus oxygen. Then we'll get this sodium manganate. Then after dissolving and filtering, what you are doing? You are acidifying with the nitric acid. So this sodium manganate plus nitric acid, it will be oxidized here and giving your sodium permanganate, which is pink color. Here you will get the pink color. This sodium manganate, here it is your, what we got? Green mass. Okay. Then after adding nitric acid, we will get the pink color. So this is the reason for this observation. So now we have completed all the preliminary test for the salt. From this preliminary test, you will get some idea about the cation presence, especially this special test or fusion test for chromium and manganese. It is almost the confirmatory test. Okay. In the next video, I will start the analysis of the acid radical or anionic part of the salt. So, I am closing it now. Thank you.